That will work. That could work. As you can see, I'm continuing working on the tailstock of my new lathe, and I just finished making the nut and the lead screw, and the thing seems to fit, and there's almost no play, so that's good. Of course, as always, I had a little bozo while I was cutting the thread, the little lock mechanism for my dials came loose and I lost track of what I was doing. That's not really smart, but it happens. So it was a bit a trial and error system making things for this, but now it seems to work just fine, and of course the thing fits in here. And I think the time has come to find a way to fix this brass piece into the quill. My idea was to make two pins out of threaded rod and then drill and tap, of course, and put them here, 6 mm. But the thickness here I think will not be enough to use 6, it will come too close to the threads. So 2 pins, 4 mm, it will be. Oh, this wasn't the plan. I have to shorten this pin a little bit, and then it will work. Right, let's do the other one, because I want 2 pins. Because my 3.2 mm drill bit here is broke, what I will do, I drilled as deep as I possibly could, and now I will drill with a 3 mm, which is of course 2/10 too small for my tap, but we'll see what happens. Good, I think we're getting somewhere here. This seems to work just fine, and it spins. So that's good. Now, I would like to use this bearing. That is a tight fit here in the middle, but of course the bearing comes right here. When the spindle is completely in, this bearing should touch more or less the quill inside here. And I need to think of a way to keep this bearing in place so it doesn't slide. So here make a pin system or something. And of course also to prevent this bearing to go in the bore, I think I will reuse this plate that already has 4 mounting holes, same as here, so it can go in. And I also need a top part, so the bearing will be squeezed between 2. And the top part, I think, is hidden in here. Because parting off operations in my USSR lathe just doesn't work, I installed my workpiece here in the Celtic, and I will give it a go with the spring-loaded parting blade. Now, I never used this thing on this machine, so let's give it a try and see what happens. I have to stop because my tool is gonna touch this useless shoulder here. So first I will cut it off. While we're here making more or less useless cuts, let's see what this machine can do. This was a 1 mm depth of cut. Let's try 2 mm. It doesn't sound happy. So the 2 mm cut was a bit too much for this poor little motor. Shit. Ah, gotta love it. Next test. 1 mm depth of cut and 2/10 of feed. The first time it was 1/10. Yes, now we're talking. Right, I will reinstall the cutting blade and continue parting. out the blade a little bit. I measured the thing and I suppose I made a little mistake somewhere. I think my parting tool here works absolutely great for this machine. The only problem is I had to cut so deep that the ship clearance became a real problem in here. So I took the part out and I cut the rest off in the bandsaw. So I will just finish my part here, playing a little bit with my new lathe. Fantastico! To drill the 4 mounting holes in this part here, the easiest way is of course to put it in the milling machine and then find the coordinates using the DRO. But so I can use maybe the next best solution, and that is of course the Zeus book. This is a viewer gift, so thank you again. Very nice. And in this book is a calculation system for hole patterns. But I think in this case it's not really handy. Because what they do, they install the 4 holes and they indicate the distance between the circle, the pitch circle of the holes and the center of the holes. So this distance here, I hope it's clear. And then there's a little calculation to do and give you this distance. And for me it is 8 millimeters something. But to figure it out on the milling machine, I don't think it's a really handy system. I think what I will do is find the center. That's not a problem. And then all I have to do, if I have the center, is move out the radius. One side, the radius, other side, go back to center, and then radius, top side, center, radius, bottom side. I never did this before, so let's see what happens. Looks good. First I made my 4 little indents here and I marked the numbers that are on the dial, just to be sure. And it seems to work, so let's drill holes. All that's left to do now is to install the 2 rings here on the shaft that will hold the bearing in place. And of course also buy new screws, because I have only 2 and I need 4. To hold my 2 little rings in place, that's gonna squeeze the bearing here on my shaft. I was thinking of an easy solution, because roll pins could work very well, but I don't have. And then I thought maybe put some set screws or whatever kind of screws in here, but I don't have. So I came up with the idea to drill completely through and then put a piece of welding rod in here and then rivet the heads. I think that could work. All it needs now is a hand wheel, because like this it's really not easy, of course. And this is the hand wheel that came with this thing when I bought it. And I think it's a little bit too small. I don't think it's the original one. But I have this thing from a valve with a square hole, so of course it will not fit in here, but I think this will be better. So I suppose all that's left to do is to bore out this hole here, make it fit on here, and set a bolt of something in here to hold it in place, and let's go for it. According to the machinist handbook, there is, of course, as always, a very specific angle which we need to use to install grub screws and set screws in hand wheels and all this. But I don't care. This my project. I do it my way. And as you can see, my way also works. I think it works. Next thing to do now is, of course, making the bottom plate to clamp the thing in place, and also the clamp for the quill. But that will be for another video.